Hi everybody, my name is Ben Cotton. I'm a Java programmer. My area of specialization is in the low latency, high throughput specific use cases typically found in capital markets, trading. All right, better. I speak loudly anyway, so hopefully you can hear me independent. Okay. What I want to talk about are advanced Java data locality and IPC transport solutions. The product that Mick presented, App Dynamics, is a product I'm very fond of. It's a product that I use, my client, JP Morgan. One of the things we're tasked to do, but it will, quick story about why this presentation is relevant. In December of 2012, JP Morgan suffered what was called the London whale losses, trading losses. In a single day, they lost $7 billion US. That was a ridiculous and outrageous spasm of capital markets fury, and it was quite embarrassing to JP Morgan personally. They were called to testify both before the United Kingdom's Parliament. Locality issue, right? JP Morgan was called to testify both before the United Kingdom's Parliament that regulates capital markets and before the US Congress that regulates misbehaved capital markets furies. That was certainly one of them. Jamie Dimon himself, who's the CEO of JP Morgan Chase, was one of my end users in this last project we had. And our mandate was to render and aggregate real-time liquidity risk. Okay, it was pretty much a blank check, so that this embarrassment of what happened won't happen again. One of the things you have to do to stop from what happening again is you have to render and aggregate real-time liquidity risk interactively, which is a problem that isn't typically solved with liquidity risk join points to trading decisions. The reason this presentation comes about is because using tools like App Dynamics and application performance management tools, we discovered things like stop the world garbage collection, I'll melt the world, or whatever, I'll stop the world, I'll melt with you. Something we weren't willing to do, because the stop the world garbage collection event is an event of such outrageous and dire consequences. Just being able to track its appearance and its trajectory is insignificant if you don't have remedy and the ambition to render and aggregate real-time liquidity risk. So this tool is fabulous. I was hypnotized by the sparkling, star-spangled capabilities. They were brilliant and capable, but it led to this single frustration. We want to get rid of it, not identify it. So what we came up with was the ambition to leave Java behind. To use Java's ambitions, but to leave Java's pedantic necessities behind. And that includes keeping anything that's medium-lived on a heap. Because the whole notion of doing that betrays the notion of surviving it, okay? So if you want to stop stopping the world garbage collection, what you do is you take your objects off the heap and you put them in decades-reliable resources like Linux native shared memory. Another thing that we were intolerant of is we deploy our computational operators and operands. In other words, we deploy our algebra. Our computational algebra is deployed only on supercomputers. Java has no priority to accommodate the supercomputing use case of any kind. You may know, sorry, whatever gizmo that is. It's one of these things you can drive race cars on your JMS. I bet it is, but anyway, the idea is that we needed someone who could take our locality of our operands off the heap, because we're not going to tolerate to stop the world. We're not going to not only going to identify it, when we identify it, the whole concept we're going to erase, even if it means betraying Java. Okay? The other thing we're not going to tolerate is the silliness of transport providers who only give us UDP and TCP as possible transports. How outrageous is that when supercomputers provide no network hops? It's outrageous is what it is, and it's unacceptable. Jamie Dimon ran this big check for us, getting us all our toys. And we have to, no, we're going to use Java for our purposes, and we're going to bastardize it. So what do we look like? We want to look like Java pirates, because that's what OpenHFT is. It takes the ambition of getting Java out of the way of its stuff. Okay? That's important to know. So if you want to stop the world garbage collection, get rid of objects on your heap. Has anyone ever heard of sun.mist.unsafe as an API? Yeah. Okay? Does anyone know what it does?
Allows direct memory access without any constraints of Julia.
Beautiful. It gets Java out of the way of itself. And in so doing, it becomes a self-loathing API package. Of all the bigotry, to call it unsafe is just technical bigotry. It's outrageous. It's a self-loathing package, okay? And they take polls on whether or not to allow it. What you do is you insist on it. Because to call something unsafe either means it can't be used or it's misnamed. It's a self-loading API package. What it does is it allows you to create arenas of memory that follow rules and behavior that meet your expectations and obligations, not the traditional Java runtimes. So, OpenHFT, wave up your pirate's flag and tell Java, get out of the way of itself. Okay? That's the story of OpenHFT. It is disruptive with its ambitions to make Java do better things. Let's talk about it. Focus. Okay, good, of course. I'm on the Windows side because I'm told PowerPoint's better. I don't know. Anyway, okay. What's the nightmare that would not die? The Java heap, okay? Okay, there's some cartoon. I don't know if any of you subscribe to the Mechanical Symphony Forum. It's run by Martin Thompson. It's a treasure, okay? It's a treasure in terms of low latency, high throughput places where the entire technology stack is consumed and shared and volleyed up, like children in a playpen, like throwing their toys at each other. That's what the Mechanical Symphony. This particular cartoon comes from Nitsan. I forgot his last name actually, but Nitsan is a frequent contributor, and this is one of his great contributions, is this cartoon. Get out of our way, heap. Okay? You will not die, so we're going to ignore you. Okay? We're going to go off heap. OpenHFT is also it's now a branded product where Peter Lorre, who's a low latency treasure, also in the playpen of Mechanical Symphony. Peter Lorre has built a branded product which is called OpenHFT, Open Higher Frequency Trading. Okay, but what it is his solution to sit in front of sun.mis.unsafe, say it's fine, trust me, and of course it's fine. He's not going to put up with the bigotry of Oracle and other Java gatekeepers. It's fine, it's needed, it's necessary, it's exactly as you say. Okay? It's a way to allocate and deallocate and manage arenas of memory that behave your expectations and obligations, not some historical right runs run anywhere ambition. Okay? So, what's the problem is, for real-time Java deployments with the strictest service level agreements, stop the world garbage collection activity happens on medium-lived objects. Okay? If you're long-lived, you go to tenured space and you live there and you do your job. But if you're medium-lived, you become dereferenced, then you have to be collected. So it's the medium-lived profile, which App Dynamics can be very helpful in identifying. It's the medium-lived objects that are your problem, okay? Maps, other collections, like you say, exactly. I'm going to talk about what's called the shared hash map. It's branded as the Chronicle map in the OpenHFT suite of products. Okay, so what's the remedy? Well, design Java deployments and developments so that medium-lived objects, like Hashmap, are taught a new trick. And that is a simple trick. Go off heap. Okay? Just go off heap. Okay? Now don't go off heap with NIO map files. They have this silly temper tantrum where you can only have 2 gigabytes per operation. There's some absolute reference to some 2 to the 32nd, whatever it is, int, whatever, okay, that betrays you. To allocate 1 terabyte with NIO, you have to do 500 calls. If you do unsafe, 1 call. So have the courage to be unsafe. It's way better. What type of hash map are we putting off heap? Now, everyone knows that hash map in the Java world is its own temper tantrum of capabilities and self-loading identity crisis. Now, that's just, now, I have some convenience to say that because there's actually a role for each of them. But in my world, Java.util.concurrent Hashmap is the only real player. But that's to betray other real use cases where they're useful for other reasons. So what type of thing are we putting off heap when we go off heap with OpenHFT? Is it simple hash map? Is it a synchronized hash map that has high contention? Is it a Doug Lee style, Java 5 and up concurrent hash map, which is lock striping, and all other truly concurrent, okay, truly thread safe. That's the key. Truly concurrent, truly thread safe. Okay? That's what you want, in my use case. Or is it something completely different? Well, it is something different, okay? It takes a hash map and gives it concurrency, not just from threads within the VM, but within native processes executing in the Linux process address space. Now that is disruptive, okay? Because you have thread safety, okay, and true concurrency amongst processes, not just threads within a virtual machine. But that doesn't allow you to use the native Linux operating system from a process view in a way that goes back to the old System 5, IPC, Inter-Process Communication Facility. But let's look at more. Let's look at more. Okay, so what is OpenHFT? It stands for Open Higher Frequency Trading. Okay, what it is 100% open source. It's designed to empower higher frequency trading. Okay, there's two known and ubiquitously published URLs. One is the GitHub site, where all the developer source and all the unit tests are, and the other is the brand new OpenHFT.net, which is where the products are being branded, the training, and the star-spangled banners of like, let's go off heat, is being sung. It provides modules that empower ultra-low latency Java deployments to achieve real-time compliance with their strictest service level agreements. Okay? At JP Morgan, when we want to render and aggregate real-time liquidity risk, if we have a 496 stop-the-world pause of our entire grid, well, 496 seconds is almost 10 minutes. Okay? You have all these quantitative, all these quantitative, mathematical algorithms that come from the quants to render the stuff based on positions and, all the market data, reference data, all the different things that act as operands into this computation. And under certain conditions, a 496-second garbage collection event on the grid that promises Jamie Dimon he'll have interactive real-time stuff? Java, goodbye, get out of your own way. Sorry, we're not going to tolerate it. It provides isolated modules so that you can do your own GC marshalling, demarshalling, thread safe, IPC safe, inter-process communication. IPC is inter-process communication. Instead of thread-to-thread concurrency and safety, you have inter-process. Threads and JVM in this process, threads and JVMs in this process, they'll use common shared resources at OpenHFT to coordinate safety across processes, not just virtual, not just across threads in a VM. It's being branded. There's a thing called Chronicle Q, okay, for queuing. Chronicle Map, which is the only thing I use, frankly, so this presentation is biased terribly towards Chronicle Map. Chronicle Engine, which is a data transport framework. This is coming straight off the presses, so I'm not sure exactly what Chronicle Engine is for a use case. It has a Java runtime compiler. Within the Java process itself is a JavaSIG. Okay? So when you provide an interface that you need an implementation class, you don't have to do it from a command line or an IDE. The process that keeps custody of the off-peak operators and operations, operands and operators, will also compile for you your on-the-fly interface. If you can provide it on the fly, we'll build an implementation on the fly so that you can bridge to off-peak bridges. And that capability is off-peak, on the fly. All you provide is an interface. We'll show you how to do that. Thread affinity, okay? On Linux supercomputers, every domain I deploy to has 240 CPUs and 3 terabytes of RAM. You don't typically get that at Best Buy, but in this type of supercomputing, 240 CPUs and 3 terabytes. That's a nice juicy spot to compute on. There may be reason for you to diversify your CPU domain to work specifically by affinity. In other words, certain we have these state-of-the-art. I mean, I'm not sure the providers we have all the distributed executors and collecting, notifying futures. But we have distributed executors that distribute work across processes, not just threads. So it's grid pool executors, okay, things like this. And collecting notifying futures that collect all this in a map-reduced kind of way, future.get. All these things come with this, including the ability to diversify your physical CPUs and homogenize them or segregate them based on some quirk, working in some type of computational permutation might be better. Transfix is a specific product for those who do the bid offer trade game in financial markets. Fix is OpenHFT is building a transfix engine, which is going to blow everything away in terms of low latency and high speed. Now, what is OpenHFT in 2 words? It's a solution that empowers Java developers to deliver the highest performing and most flexible data locality. Do you want to be on heap or do you want to be off heap? And IPC transports, okay? Which means if you're on a supercomputer and you have no network hops, there's no reason for you to take UDP and TCP as your only transports. That's the old, you're doing this silly, like, it's a little childish playground dance across an OSI loopback stack that gives you nothing because you're not crossing a network interface card. We're going to show you the merits. Okay, the merits are competitive. Well, if you're in the supercomputing use case, you must have OpenHFT and not anything like JGroups or anyone who claims to be a Java transport provider and they give you only UDP and TCP. You need to take that, shelve it, and bring up OpenHFT and consider it if you're using a supercomputer. That's a no doubt about it. Sound and complete valid statement by me. Trust me. So part 1, let's look at OpenHFT as an advanced Java data locality provider, which means we're going to go off heap, okay? And by going off heap, we're going to stop the world garbage collection compromises. We're stop the world. Okay, little silliness about Hashmaps. Hashmaps have their history. The core Java util Hashmap is a non-thread safe key-value pair data store. That's all it is. Introduce multiple threads interacting on that, and instantaneously you'll have some type of corruption. Just as fast as your finger gets off the return key, it'll be corrupted. That's just the nature of it. It's a simple, kind of like, I don't know, kind of like the hello world of Hashmaps. That's really what it is. A non-safe key-value data store. I don't know why you'd use it. Apparently, someone would like to. Collections.synchronized Hashmap is just the tease of all teases, because how does it improve it? It introduces one lock on the whole key-value address space and says it's safe. Well, so what is safe? You get perfect contention because a second thread joins the party, it's denied because a single lock controls the entire address space. So what it is, it's worse because it teases you with the notion that it's thread safe. Well, so what if it's thread safe? It's still only one thread at a time can run on it. So it's not multi-threaded. It's almost like, well, it's childish. Now, Doug Lee and Java 5 introduced Java util concurrent Hashmap and a notion of strip locking, where segments of the address space are governed by individual locks. Okay, so you have multiple locks, and the resolution of that can be tuned by the API or by whatever, whatever your need might be versus lock versus resolution. It's addressed by concurrent Hashmap. Concurrent Hashmap is quite an eloquent data structure, written by Doug Lee, literally. Okay, so if you want to commit like Harry Carey with your ambitions to be like Doug Lee, take a look at the source code because it is a coup de grace of eloquence. But I don't want to look at it. I just want to use it because it works. Seriously, it's one nasty thing this babysit with. If you dare to teach yourself, don't dare to do it. You'll be sorry. Well, I was sorry. I did it anyway. Moving forward, what is the problem with Doug Lee's concurrent Hashmap? The problem is stop the world garbage collection. Okay, he's a medium-lived object in almost all of my use cases. So at some point, this virtual machine is going to ask that the concurrent Hashmap be vulnerable to a stop the world GC event, in which case we're going to suffer a 496 service level outage, which is basically we're out of business and can't use Java to continue. So that's the problem with the state-of-the-art in concurrent Hashmaps as Oracle delivers them. They're vulnerable to stop the world garbage collection events. This is another thing that AppDynamics gives you very good autopsy visualization, interactive, where your objects live. The idea is this: if you're an infant object, you get promoted on a minor event into a survivor space, 1 or 2 survivor spaces. After that, you get promoted into a tenured generation, and you live what's called the tenured generation. Okay. There, you live until you die, okay? And if you're medium lived, your death causes a D reference and a GC cause. Okay, a major event, reclaim your space, compact you, all this stuff, and it'll cripple your service level agreement. So this is the anatomy of what happens. Okay, very simple. Different collectors, as was pointed out, and you mentioned Azul Zinc, which gives you C4, continuously compacting, collecting. Yeah, so something. The C4s are relevant because all four available at the same time means you have what Oracle should have given you but didn't. Okay? So you use a non-Oracle collector and you got what Oracle should have given you but didn't. Now, as an outrage to both Oracle and the fact that I don't have direct access to my clients who are getting Zing and doing that, we go off heap completely. Okay, so the whole notion of operands living on a heap, we vacate, we abandon ship. This picture here is the whole magic of what OpenHFT does. It's hard to go over this interactively in a large group. I apologize for that. I'm going to try to do it briefly. If you can picture this, these are Linux processes. This is a JVM with Linux process ID 1, and this is a JVM with Linux process ID 2. Okay? This is an interface that you provide, okay? You go into it, this interface calls an API provided by OpenHFT. OpenHFT builds an off-heap bridge to the native Linux address space. /dev/shm, if you do an ls from a corn shell, you'll find that this is native Linux shared memory, okay? And it acts as a good place to put memory map files. You're going to target memory map files. This is an excellent place to target them. Because it acts like, I don't know if they call it in Microsoft, like RAM disk or something. It looks like RAM. It has a file system view of RAM. Well, this is what this is. This is a file system view of shared memory, okay? And it's not platter memory, it's solid state. Okay, it's the kind of memory you'd hope to see in a Linux. But even though it has a file system view, everyone knows about memory map files. If you don't, you probably need to learn them before you look at OpenHFT. The idea is this. By calling this API, your view of it was called a chronicle hash map. Okay, it's a concurrent hash map. Is not on heap, it's now off heap. Okay, because he does the library does the plumbing. Now, we're going to show a picture of a producer of price ticks that produces the ticks off heap, and a consumer of those price ticks in process 2, which does the exact same API call to consume them. To mutate a hash map, you share a hash map book at the QSIP, at your price, and you get it using the same way. A small variant though is get using, not just get. Okay? By using get using, you get a 0 copy. Okay? Now, another mortal sin of Java, in my opinion, is not having explicit call by reference. Now, you might say call by value, all it does is transport references, but it needs an explicit call by reference if you want to have references as the, I don't know why they don't have it, okay? In C++, you put an ampersand in front of int type I, and you get the address of it. That easy. I now hold Java as some arrogant freaking write once, run anywhere, like whatever it was. Why don't you have an ampersand operator so call by reference is explicit? Anyway, Peter Lowry in OpenHFT returns the notion of call by reference, so we have 0 copy transports for consumers, okay? Now where they want to introspect on that 0 copy, they'll have the reference so they can decouple it and get offsets into the whole data structure. So again, another thing that, I don't know. I mean, I don't know why. But why not just provide it? They're supposed to be C++ familiar. Where's my ampersand operator for call by reference? Anyway. So this is the ambition, okay? Through the API, you can take your interface. Let's look at it. Okay? Here's an interface, okay? This is a fixed income vanilla bond, okay? Every bond has a symbol. Every bond has an issue date, a maturity date, okay? We have getters and setters for that in the interface, okay? We have atomic adds, okay? Just like Java util concurrent, not atomic, gives you blocking, checked and act kind of additions and thread safe without having to have synchronized or locked. You don't have to use reentry block or anything. So too does OpenHFT give you that, but it gives you a process safe view, okay? Java Util Concurrent Atomic gives you non-blocking thread safe. This gives you thread safe and process safe, so IPC safety with the ambition of Java Util Concurrent Atomic. Get coupon, set coupon, add atomic coupon, okay? Get symbol, set symbol. And prices. Now prices, if you work in capital markets, locality problem. Prices, there's no such thing as just a price. What price? And what kind of price? And what you know, pricing is more finicky than fashion. It's like, it's very, very, so there's call prices, there's par prices, there's bid prices, there's ask prices, and there's maturity prices. And that's just a simple flavoring of the pricing techniques you can get with capital markets use cases. By providing this interface, okay, we give you, that's all you need to provide to build an off-heat map that will provide your ability to both mutate price ticks and consume price changes in a way that you're not vulnerable to stop the world garbage collection, ever. Because this operand lives in the native Linux address space. Oh, one more thing. Will OpenHFT work on Microsoft Windows? Barely. That's the truth. I'm supposed to say yes. But the people who are building this are Linux devotees of unforgiving, yes?
How does memory get cleared out? Is there a concept of memory leaks or delete like in C++?
Great question. Calc and free and I forgot the object-oriented ones. The new operators, the Calc operators, you have an API. The answer is you have an API. Okay, and that's a great question because where you take back creating arenas of memories, to obey your expectations and obligations, part of your expectation is going to be that you have no, you have to retake your own custody. You have to create your own garbage collection because you're in a playpen of great capability. You have to clean up your own playpen when it goes garbage. Correct? You have an API as answer.
So have you just brought C++ with a Java layer on top?
I would say yes. Because I'm not ashamed of it. I'm not ashamed of it. And if those, I mean, I laugh with you too. This is it. Java has some great ideas. Java brings a lot of people to the problem-solving party. But Java leaves a lot of problems behind that it still can't solve because it won't get out of its own way. So your point is, I agree with what you just said, but I'm also proud that someone has the courage to just take this and give it a shot, because it works for me. And if I'm the only one who it works for, well, I'm still proud of it. That's what I'm talking about. Okay, okay? So I'm glad you're smiling at that. That's how I feel. It solves a problem. I got Jamie Dimon writing checks, so that's how it is. But thank you for that.
So do you consider using C++?
Of course. But these people who sit in these deep, dark, I mean, these are secret craft society of Java practitioners who do taboo things. They have a certain self-guilt about it. I should stand up and be proud. You know, like, because they should be. To dare to do it, I'm proud of them because they solved my problem. And that's just a fact too. But yes, your point also is well taken. Should we have done it in C++? Yes, but C++ is itself taboo and dark craft now. I mean, the only thing you write in C++ now is Java virtual machines. So, I really, I mean, we have to be with the times to get funded, and we have to be political. And so we're trying to honor everybody, that everybody have fun, because we should. That's just the truth.
Is there any non-political reason why you chose Java?
You know, there was a time when I would have really chosen just C++ just because I had known it, but there is a reason. Because more people trust learning this stuff by having a Java bridge. There's both the Java bridge to the Java good things, the Java safe things, and also these armor-plated, like, come on y'all, dare you to come this way. This way's available. It's all there for everybody. And Java was ridiculous to just have arbitrary write once, run everywhere type of ambitions, because all that does is I can run an applet with some hijacking athletic penguin. I'm doing jumping jacks on a browser, and in my, my steering wheel has enough memory and stuff now, I can probably do it on there. But I don't want to do it. See, I I want my Linux decades reliable dev shared memory, okay? Native operating system. In one statement, I can allocate 3 terabytes, okay? Denial, thousands and thousands of 32-bit cents. Okay?
Question for you. Do you access this from C++? Is there API integrated with it?
No, there's not. No, there's not. Not to my knowledge. That's the point. So all these, see, the tragedy is, the inspiration to do all this, we leave behind the language that gave the capability, and it gets left behind almost unjustly. Hey, everyone has to have a martyr. Okay.
Well, I see you both mentioned a tab / hashtag channel.
Yes.
So you have to actually do run this. If you have to allocate a run this first.
That's a great question. I do not see. I don't know the answer to that. See, okay. In the Linux versions, it's System 5 Release 4 compliant, and that's getting taka like. Dev's SHM is a known IPC resource of decades old reliability and familiarity. Okay. There's things called, like in section 2 of the Linux kernel, shared memory attachment, shared memory op, shared memory get. Those are kernel system calls that allow you to operate on that operand in a way that you can count on it being the best possible medium. Now it could be a magnetic platter if you're some masochistic type of Linux builder, but in familiarity and reliability, it's always been the state of the art of the medium is the best. The fastest RAM on your platform is included and partitioned to be there. Okay. Yeah. The best answer is to look up System 5 IPC. Yeah. The old systems, okay, that's what that shared memory is.
So I heard that the unsafe related API is going away in the future versions of Java.
It was voted away. It didn't become any safer. So it became unpopularly unsafe. And when you're unpopularly unsafe, well, sweep it aside. It's really ridiculous. It's the most bigoted name I've ever heard for an API. Unsafe. Silliness. Silliness. It's a self-loading API.
But it's still gonna be there?
Java 9 is introducing a new memory model, and all the unsafe methods will become part of the language. You will be able to go into a particular variable and invoke a particular instruction, such as add and replace, or get the offset directly by using the language syntax. The GSR for it is still in the works, but if you go into the WE's concurrent, you can see the draft for it.
Will it be in language or in the
It will-
JVM?
It will be both.
You never know. We don't.
As soon as it's shared memory, does it survive a process death?
What was that question?
It's shared memory.
Yes.
Is it named shared memory?
That's another good question. I don't know the internals of this.
Yeah,
Of course, in System 5, you have to do an attachment, you have to do an operation, and you have to do a get by key. So you won't collide, you can isolate. There's notions of isolation, all this is true. Now, the implementation, I'm sure they do this. I'm not familiar with it.
But if you restart the process, will it see the same data? Or
Absolutely, absolutely. Certain transactional guarantees are made by OpenHFT with regards to its expectations and obligations for how shared memory behaves with anybody. And they document, they have this little, okay, in the writings of the people who build this, they call it expectations and obligations that they have for you to work with this. And they write all this out very eloquently. Of course, they're all over the world. I don't know the exact answer, but there's isolation guarantees by key, and they take custody of it. See, when you have they manage and isolate it the same way System 5 will do it. You have to attach to it, you have to get a key, and you have to operate on it. Then you have to release it, detach it. Those old shared memory, section 2. Look up SHMAT, shared memory attach. SHM get, section 2, the Linux system call. Okay? Executing the address space of the kernel, not some library. Okay, this is old school Linux. Okay? All right. Been done since the 70s. Thompson and Ritchie. Well, yeah, it's Ma Bell Linux. It's Thompson and Ritchie. The guys who wrote this stuff are Thompson and Ritchie. Not Cardigan and Ritchie, Thompson and Ritchie. Cardigan's a book writer. Which he's a brilliant person. Brilliant and generous and kind. But this is Thompson and Ritchie.
What role did J.P. Morgan play in developing this library? Is it open source, or do you have to write a check to give you?
It is wonderful. It is, okay, if it executes, that's a great question. People like Hazelcast, people like Terracotta, people who claim they're going to be the off-heat providers of Java operands, well, guess what? They don't give it to you in the version that's off-heat. They have this brilliantly, I'm not going to be critical. They're good people too. But if it executes on the stack and it has net.openhft as part of the package, you get the source to it, period. Okay? If it executes, you get the source to it, period. This is really, what did J.P. Morgan have to do with this? We kind of, I don't know, we have needs too. We kind of give them we kind of lifted them out of the playpen and threw them in the air and gave them little toys to think about, like, we love this, do this. It gives them validity to be dark and mysterious creatures of practitioners that the Java community is scared of. That's how I describe it. We kind of open the doors and say, come on out, it's perfect. You're doing nothing wrong, we love you, you should love yourselves. And they do, and it works. It works. We feel a certain synergy. I mean, these guys get on a plane and come up and sit with the CTO of risk at J.P. Morgan, and it's very interesting, that type of thing, because the CTO of risk is himself highly quantitative, multiple decorated patents and algorithmic. Risk is highly quantitative. It comes from energy physics and mathematics. Everyone at J.P. Morgan at a certain quantitative level has PhDs in physics or mathematics that are in quantitative risk. I don't have that. I don't know, I'm kind of pimping it in a sense, like, go on. But anyway, this is all you have to provide. All you have to provide. And from this, we can do things like, okay, how to write, okay, what you do, okay, you provide this interface, okay, you pass this interface to this new direct reference static method of this static API. This is the only thing in this API is static methods. You pass your interface and it gives you a new direct reference off heap to your bond VO reference. And you can start doing magical things with that reference, including assigning Q sub values, okay? Okay, this is where the locks take place in shared memory to guarantee isolation, durability, things like that. I forgot the exact words. It's written in the prose of the ambitions for these types of data structures. And from there, you can now mutate off-heap price ticks and the like. So we have this, we locked it off. Now this is off-heap, okay? This cannot be garbage collected. If you go back and if you want me to challenge that, well, guess what? This is the penguin who rules. This penguin rules this penguin. This penguin here is one serious bird. And it says, because these JVMs live as little bitty processes from her viewpoint. And coming into her native address space requires, you know, regality, respect, and proper. You have to dot your I's and cross your T's. Okay. Okay. So anyway, this bird is down here. Kernel address space, dev shared memory. One step further, you're mapping into Intel kind of nonsense. It's the kernel address space. It's just a hardware abstraction layer away from getting physical. Okay. Now, the ambition here is being off heap. You can mutate at a fury with no worry of garbage collection. Okay? No more 496-second pauses ever in our grids. Okay? So even though we're doing liquidity risk, mutating price ticks is an easier way to do it, because if you're consuming price ticks and you have some spread that you can make money on, you better not be garbage collecting while that spread becomes tradable but not available because you're collecting garbage. That's obscene. Okay, that's obscene, that's offensive. Pagers should go up at night, programmers should get fired, and bankers should cart Java out with the garbage it collects. Okay, this is all just a bunch of, what I'm showing you here is producer and consumer from all people. Everyone knows Hashmap APIs. You put it in, you take it out. Okay? Then you do something with it. Okay, that's simple. The only thing different here is we're doing, we're locking an off-peak data structure with a multiple process view, not a multiple thread view. Okay? Actually, it is, well, it's a relatively, it's multiple thread. The lock is guarding against process access and process contention, not thread access and thread contention. Okay? And of course, it's elegant. It doesn't leave the ambition. Of course, these guys couldn't do it that cleverly either, but they have the ambition. They have lock striping. That's about all I'll say. They have lock striping, and it's configurable to an API how resolute you want that striping to be to contention. Contention versus striping is just a management of where you want to be on that curve. Okay, so moving forward. Oh, another thing. We want to show you something that's very impressive and we're very proud of. We have the ability to add atomically from the view of, everyone's familiar with Java utility field concurrent atomic in integer, how you can add and blah, blah, blah. You do things at once. So we can add atomically a maturity date, okay? So we can put 30 years on top of that maturity date, typo somewhere. And we can do it atomically from the view of processes without locking. Okay. Add atomic coupon. If you want a zero coupon bond, just take the negative of the current coupon and it becomes zero coupon. You can do that atomically from a process view, not from a thread safe view. It's more than just thread safe, it's process safe. And of course, everyone's familiar with, what's that called? Reentrant lock. And there's an API in Java called reentrant lock. Okay, reentrant lock gives you, well, the interface is lock. And you get reentrant lock and some other type of lock. But the idea is this. You can have an explicit lock, okay, from process, if you fear some process contention that isn't managed, the equivalent of using conditions and things like that from the Java API, this works not only across threads, but across processes. So if you want to synchronize process contention to a critical section, you have a busy lock entry and then unlock entry.
Quick question. So I presume you almost exclusively operate with string constants which you do not split or concatenate and from other primitive types, because otherwise you still incur garbage collection, correct?
That is correct. That is correct. And that comes into a caveats page. They're working on that furiously, and that's the focus of their current ambition, because they're actually very delighted with themselves with HFT, and they should be. And they should be. What you're pointing out is, what I think you might be pointing out is the problem, can fully transitive object domains be represented as key and values? The answer is no, they cannot. Okay, right now, there's certain advantages to primitive only. Okay, and where you graduate, okay, KB custodians onto objects that are arbitrarily transitive in their object graph potential, they have weaknesses there that they're quick to caveat, happy to caveat because it's the truth. They don't have the capability to give you a fully transitive object graph as neither the key nor value generic placeholder. Now, that's the point you're making. That's well known. Okay, it's well known amongst them. They say that certain. Well, I'm not going to apologize for them, but it's in their high consciousness, and they're working on ways to reliably make a fully transitive object graph the participant as both the generic key or the generic value. So summary, okay. Of course, you have multiple thread safe operations. That's just taking what we did. You have that anyway. Okay, multiple thread safety is done with the chronicle map. You have IPC safety, contention from another process at its intention to mutate or access a critical section or any operation on a shared chronicle map. And it is IPC state. It's IPC atomic also. You can do atomic operations. You can add on some numeric within that. It's a zero copy. Okay. The API gives you the ability to use get using, which gives you just the reference. Okay, and then you can isolate from the reference which part of either the key or value you want. Now this is important because zero copy is important because sometimes maps have big values which are themselves monstrous things. Okay, call by reference. I'm not going to call it. They hate me calling it call by reference, but I call it call by reference because zero copy is you return a reference and not the value. It's not a value copy; it's a reference copy, and we're branding that zero copy because you're not returning any data; you're returning the reference. GC free marshalling and demarshalling. Okay, what was addressed to in terms of like every operation on every operand, every part of the API is garbage collection free. Okay? But it does introduce the notion that you do have to do your own garbage collection. That's true. It comes back to you. So where you have calloc and malloc, you now have free and but those type of operators you have to return to your toolkit of capability. It's true. Nothing's perfect. Now, here's the startling thing that I finally got them to agree that this could be in the slide. OpenHFT has the ambition to provide the symmetry of Java util concurrent API support across native Linux processes, not just threads. That's awesome. That's really awesome. And nanosecond transport latency. Okay? Now we're going to show you how this works because if you no longer have to go through some Oracle-blessed transport provider and some Oracle-blessed Java certified stack, you can go native yourself. And when you do that and you have dev shared memory as your own transport, well, watch out. I'll show you now. I will show you now. First of all, just talking about the craziness of, this is what it looks like if you're using Doug Lee's concurrent hashmap. God bless him. It's a brilliant data structure. Brilliant data structure, but it suffers because it lives on a heap. And you see this thing right here? That's 496 physical seconds. And this is a real test done with a real set of inputs and outputs. Expectations and obligations in this test were real. And this result of 496 seconds is so startling, so criminal, and so just absolutely loathsome that we take anything that's self-loathing in Java and say, stand tall, you deserve to be heard. You're probably right, because this is unacceptable. This takes Java and makes it a little silly toy of that. Does that penguin, Duke, whatever it was. I mean, it's silliness at this level when you got this much money at stake, and this happens in a real test of expectation. It's almost 10 minutes. If that number was 600, it would be 10 minutes doing nothing. It's no good. Now, if you use OpenHFT's shared data structure, you get no GC of any kind. Not nanoseconds, not picoseconds, not theoretical time-space continuums. It does not happen. It's GC free. So that 10-minute delay becomes nothingness. It's not a concern. Back to the future. What can it mean for the future of caching providers? I mentioned Terracotta, I mentioned Hazelcast, there's things called Oracle Coherence. One of Java's big delinquencies is not having a formal caching data locality solution. It's really compelling. If it doesn't include the notion of off-heap providers, it still won't. I'm very active myself in some of these discussions in the community. OpenHFT and its Chronicle vanilla shared hash map sits in perfectly as a potential JCache compliant operand, period. Someone just has to write up, see this code here? That's all you need to do. I did it for the InfiniSpan trunk because the InfiniSpan repo is literally 100% open source. Trouble is they don't have an op-heap container yet. So we're trying to get a lot of people excited about a lot of different things that they should have no guilt at all, okay? And they should just consider what it would mean to work together. First of all these notions of terracotta flavor of off-heap caching excellence and a Jumpfire notion of off-heap caching excellence, forget it. There's no such bigotry amongst players like this. It's It's a playpen of love, like you put mine, take a toy, you get mine. And there's no discrimination of any kind. There's no notion of it. Ours is the best because it's impossible to be better. It's just impossible. So this brand, you're kind of, oh, well, we could actually close this access because it's startling bullshit. I mean, shame on you people to claim you're the open source grid providers, and the most compelling part of it, you close source, just to distinguish yourself for revenue plus it is. By the way, when the dairy farmers think that they're the people who make the milk, let me introduce to you the cows. Like that. Like that. It's like that. They can do their little 2% skim-free, half and half bullshit. But you need a cow. And we like the cows. All right, moving on.
So in your HPC environment, whose grid engine do you use?
Oh, good question. We use InfiniSpans right now because we're trying to babysit them into enough steam to join OpenHFT to become a real team. And we're doing it to babysit them, okay? We played with Oracle and all that, but all this nonsense about closed source, open source, blah, blah, capability, support, F that. We want a service level agreement that meets our client, Jamie Dimon, expectation. That's all we want. And all this silliness about what they can do with blah, 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 blah. We go right into the playpens themselves where the monsters are, and we feed them the raw meat, and they show us what's good and what's bad. And they're honest about it. Very honest. And we tell them, stand up and applaud yourself.
And with your grid batch jobs, are you using something like what used to be called Condor?
I don't know if you call it, well, I don't know what Condor was, but we're using brand new things from Red Hat that's called, okay, they're called distributed executors. Distributed grid executor. And that puts across the grid. See, it's, a thread pool executor sits in one process. It has a bunch of threads, a thread pool. What we have is a grid pool. But we have obligations of a transport provider to make that happen. And we have collecting, notifying futures. Okay, so they're not just futures on a thread pool or on the expectation of some executor's return. Whatever, I'm not sure exactly, but that's what
they provide the RDMA TCP pass-through.
RDMA, good question, that's coming.
TCP pass-through.
That's coming up. They do not provide that. We're building that. 5 minutes? Okay, good. Good question about RDMA, because that's what it's all about too. It's screw this goddamn TCP, UDP kind of choicing. I mean, good.
And your long-running transactions, there's a persistence mechanism.
I don't know. Well, I mean, there's whatever expectations and obligations would come from a distributed grid executor sending out work. There's some quantitative MapReduce kind of hocus pocus that goes on that I'm not confident in terms of quantitative levels. Built behind that is what's called a collecting, notifying future, which takes across the transports the obligations of MapReducers to go. The reducers come to the mappers, and the mappers come to the custodian, and the custodian makes liquidity risk indication. I don't know the exact plumbing. When you say RDMA, that's another thing that we're happy to share with OpenHFT. OpenHFT is a transport provider. I'm going to go real fast here. If you really want to see this is all just test results. It'll just blow your mind. I'll show you some GitHub. Will you provide a link to this meeting or something? Yeah. So you can have this PowerPoint here. And this PowerPoint will give you links to GitHub tests. It'll show you transports that aren't 92 microseconds, they're 35 nanoseconds. That's fast. Let's go. Here's the traditional, we talk about RDMA. Okay, RDMA is the idea of direct process buffer to direct process buffer. This is the OSI, this is the old way, this is the 70s. Physical layer. You have Ethernet and InfiniBand, you have PDP, POET, if you're over Ethernet, IP, and you have Java APIs at certain places will match the layer, okay? Typically, the lower you get, the less likely you are to have a Java matching capability until Java 7 and Socket String Protocol, which delivered to Java its first capability of RDMA, but you had to have InfiniBand as your physical provider. Otherwise, Alan Bates and Oracle wouldn't do it over Ethernet. Of course, no one has InfiniBand. Every computer ever sold at Best Buy has Ethernet. So, I don't know, it's like McDonald's and, not having a bun or something like that. It's just unfortunate, but there it is. For InfiniBand, there is physical RDMA available in Java 7 today. What is 7 Socket String? It delivers sockets direct protocol over InfiniBand as a transport. Now, if you look at the buffer is like some hash map to some hash map, okay? Now you see an operating system, and you see a network interface card, and you'll see InfiniBand, who's the physical provider. Pow, 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 no operating system involvement, no TCP/IP, nothing like that, okay? Straight buffer to buffer, that's a high-level view. And a low-level view, well, what does it mean in terms of steps? On the right, you have the OSI layers, okay? You go through some network interface card, Ethernet driver, IP driver, TCP, UDP, some socket layer, some traditional network interface to your application buffers. If you have InfiniBand, you go directly from the physical card over the Verbs device driver into the Java VM application buffer itself. One step. Now you need that Verb device driver to take the silicon that is the InfiniBand physical card and make it, do the on-off logic physically to get it there. But that's it, one step. So this is Java's first RDMA capability. Now, I'm going to take one more minute here. Remember this, folks. We can now have the vision of Java over Ethernet doing RDMA. Why? Because Intel gifted IWAR. Imagine Intel gifting to OPEC, okay? By giving us that gift, Intel provides a way for an Ethernet driver to sit there at the same place that Verb sit, and a physical Ethernet card with a physical driver, IWAR, can now go buffer to buffer without touching TCP, IP, or anything on the OSI network stack. Nothing. It's RDMA for the best buy masses, and it'll work once it gets glued in to something. Get Alan Bates at Oracle to glue IWAR into the sockets direct protocol for Java 9 or whatever, Java 10, some future Java. Because when that happens, TCP IP goes bye-bye. It's not needed anymore. It's not, you go to Ethernet, the application buffers. Who needs this 1970s technology was reliable, but
How does it scale?
huh?
How does it scale?
How does it scale up now?
To multiple processes.
Now wait. I think the question might be, is there a need for guaranteed delivery, decades reliable networking protocols? Not for me. Okay, I need my buffer to respond to events that are real time. Now does it scale and easy? Probably not. I'm probably leaving out something dastardly and uncivil. But the notion of TCP/IP is a necessary joint point. And see, the idea is this. I want my grid participants to communicate over a transport. And I don't want it to be a stupid, decades reliable, multi-layered, guaranteed transport, which TCP/IP is. I want it to be, do this, do this, pop. And if you don't do it, I'll forgive you.
You have multiple nodes. How do they call each other?
Huh?
You have multiple nodes. How do they communicate with?
I don't know. Okay, the product is called IWAR. Okay, Intel IWAR, and the ambition to do RDMA over Ethernet. Okay, I'm out of time, y'all. This is Peter Lowry. Okay, everything you see that I showed you today, Peter is the leader behind it. Now, I told you, Peter is disruptive with his ambition to improve existing products. He doesn't want to just marginally do this. He wants to tear things down, start all over. And the glory of that ambition is perfect for us. It will likely be good for you. Some quick freaking notes on speed. When we use OpenHFT as an intragrid transport, okay, everybody's like JCache, JGrid. And JCache is the tree, and JGrid is the forest. The tree and the forest. And we're skipping around doing a little type of Red Riding Hood events in this forest, putting all this data across this grid. The average latency for internode transport when using Peter's transport is 37 nanoseconds. If we use JGroups, which is Java's de facto transport provider, remember, 37 nanoseconds for this unknown person, not unknown, but this in the shadows kind of person. 37 nanoseconds, average transport. Now, if we use JGroups, 92 microseconds, or 92,000. It's not 30 nanoseconds, it's 92,000 nanoseconds. So, if you're a supercomputer, if you're a supercomputing use case and you don't cross physical hops, you must use OpenHFT or you're committing a grave disservice to yourselves. Yeah, that's pretty much it. The rest of it is just, go visit these websites. That's it.